Hello, this video is for students who could not make it to the lab on Tuesday. I'm going to go through the lab so you understand it for the purpose of your test on Thursday. So what this lab is a way to model the different types of plate boundaries. And so what you should do is download or access, click on the PDF of the Edible Plate Tectonics Lab from Schoology, and you can follow along and answer your own questions as we go. So the first part has the background about the theory of plate tectonics. It says it combines the ideas of continental drift and seafloor spreading to explain how sections of Earth's lithosphere, called plates, move on convection currents in the mantle and how these movements cause the formation of huge underwater mountain ranges in the middle of ocean basins, folded mountains in the interior of continents, volcanic island arcs in deep trenches, and volcanic chains near the coasts of continents. This activity, you will use graham crackers to represent the different types of lithospheric plates and frosting to represent the asthenosphere to model the processes involved in plate tectonics. So I did make one change for this. Instead of using, originally there's going to be regular graham cracker for the oceanic crust, thin, small crystals, and the continental crust was going to be represented by cinnamon graham cracker with the large crystals representing large crystals in continental rock. So instead, I've switched to using a Rice Krispie treat for most of this, since continental plates are much thicker, and then you can also see the large crystals. Okay. So the first part just talks about how to set this up, and it's the divergent plate boundary. So I'm going to go ahead and set aside the Rice Krispie treat. And it says to break this into 4 equal pieces. So I'm just going to go ahead and break that. Set this over here, and I can carefully break this. Place 2 of the graham cracker pieces side by side on the frosting. Now these represent oceanic plates. Gently push down while you spread the graham crackers apart. Spread the graham crackers about 1 centimeter apart. The frosting should well up to fill the space, okay? So as I do that, what we're seeing is frosting coming in the middle here. And so once again, the graham crackers in this scenario represent oceanic crust. As they split apart, molten rock comes in to fill the spaces. And so the frosting would represent molten material coming up to fill the space. And this is a divergent plate boundary. And where on the surface of the Earth can you find this? You know, if you get stuck on these, let me go ahead and take these off of here. On the back of the lab, or the last page of your lab, there's a really good map showing the different plate boundaries. And so if you're looking for a divergent plate boundary, you're looking for any time that there's 2 lines with arrows moving apart. And certainly the Mid-Atlantic Ridge is a divergent plate boundary, the East Pacific Ridge, and so on. Okay. The next one we're going to model is continental oceanic convergence. I'm going to go ahead and remove one of these. Set that aside. And it says, lay a graham cracker and a Rice Krispie treat side by side on the thin layer of frosting. The graham cracker will represent the thin, dense oceanic crustal plate, and the Rice Krispie treat now will represent the thicker, less dense continental plate. Slowly push the 2 together, causing it says chocolate graham cracker, that's a misprint, the graham cracker to sink below the Rice Krispie treat. So we're going to shove them together. We're going to cause the graham cracker go below the Rice Krispie treat. Sorry if you couldn't see that very well. If I look to the side of this, you can see it going below the Rice Krispie treat. Okay. Question, which plate ended up on the bottom, the continental or the oceanic? What deep ocean floor feature would form at a boundary between a subducting oceanic plate and an overriding continental plate. Okay, and so we're looking at a feature where an oceanic plate is being subducted. I'm just showing you a side view. And what is this deep ocean feature? And these were the Andes Mountains. That's what we learned about in class. What geologic feature would form on the continent a bit inland? So it's asking, what are these? Name one example on Earth where this type of boundary is occurring. Again, I gave you an example already, and you can look at the map. And what is the name of the mountain range that is formed at a boundary in your example? Okay. Next, using 2 small cinnamon graham crackers. Now I crossed out the word cinnamon because I didn't have any cinnamon crackers. And what we're showing in this one would be continental convergence. Okay, so continental convergence, what we're showing here are 2 continents colliding. Well, it's kind of hard to do. What I have in the lab you would do would be, let's go ahead and remove this. That one, but that's okay. Would be to moisten the graham crackers. That would get them wet, and then as you push them together, you would see them buckling. Not a real easy way to model that. I'm going to go ahead and try it with a Rice Krispie treat. I'll take my knife and maybe just cut that in half if I can. So the idea with continental convergence is as they come together, they squeeze together and they form mountains. And you can kind of see how that might occur. No subduction occurs. This occurs, as we learned in class, when India ran into Asia, forming the Himalayas. So describe what happened. Name one place on Earth where this type of boundary is occurring, and what's the name of the mountain range that formed. And are the mountains that are formed volcanic? And we find that they are not. They're called folded mountains. Finally, the last one is transform plate boundaries. This one, as you're getting messy probably, placing 2 plates together. The graham crackers work the best possibly for this. What we're going to do is push them, and we're going to increase the friction. What you'll see is as I go, the friction is as I increase pressure, it reaches a breaking point. And that would be an earthquake occurring. So as the plates slide laterally or side by side, we call this a transform plate boundary. Are any mountains formed? No. What sometimes disastrous geologic event occurs at this type of boundary? And what is the name of a place where this type of boundary is occurring on Earth? Once again, you can use the map on the back. Okay, hopefully that gave you all the information you need to understand this. On the test, you certainly will need to give examples of these types of plate boundaries. So make sure you take a look at that map and the examples. Okay, good luck.